What's up guys, Bua Davis here. One of you asked me to make Angry Birds full game tutorial, so here it is. Before we begin, if you like my content, please like this video and subscribe to my channel. It will be always greatly appreciated. Today we will talk about Angry Birds, how you can make character animations, how to kill enemies and make different levels, and so on and so on. So without further ado, let's get started. First of all, I prepared for us some free assets, and I will leave the link in the description to all of them, and feel free to use them. But if you want to use any other assets, of course you can do it as well. I have these bird assets. I used them in my Flappy Birds tutorial, and I really liked it. So I will use it today as well. I have this bird. It's pretty big bird, so let's scale it down to 0.3 for the X and Y, and Z we don't care how it looks fine. Let's add animations real quickly because it already has animations in this pack. Just go to the animations folder if you're using the same asset as me. And in bird, you see bird 1, you will see these animator controllers. We need B1 red birds controller. So let's drag this animator into our bird. And that's it. It will create this animator and it will have this animation. Animation is basically this wing movement. That's all. Amazing. Now let's add few components to our bird. First of all, we need some collider, and I will use Polygon Collider 2D for it. So type Polygon Collider 2D and let's add. You see these green lines, it's our collider and it will work perfectly fine. Also, we need physics, so let's add Rigid Body 2D. Amazing, and our bird is ready. Now let's go and add some background cause scene looks pretty boring right now, and I have this background image. And let's drag it into our scene. Let's look how it looks. It looks fine. Now this background image already has this ground, but we can't really use it because it's not game object. It's just image, and our player can't just land on it. But what we can do, we can create empty game object in our hierarchy. Create empty. Let's call it ground. And let's see where it is. Let's place it around here. And let's add component to it, and component we want Box Collider 2D. Let's click on the Edit Collider and let's make it so it matches our ground. And let's drag it all the way up. Now we have pretty small scene and this way will work just fine. Now we have our ground object and our player, our bird, can land on it, and I will show it very soon. But first let's drag this ground into our background. And let's duplicate our background one more time and let's place it right here. Okay, our scene is ready, and let's press play and see what it looks like and what it does. Our player, our bird, should land on our ground because it already has rigid body, which is physics component, and it adds gravity to our bird. And let it compile. And here it is, our bird landed. Now one more thing before we continue. Let's select our bird and let's go into rigid body and freeze rotation on the Z-axis, because otherwise it will have weird movement, a weird rotation, and if we want we can always change it, but for now let's freeze rotation on the Z. Also, as I already mentioned, our player has physics component, gravity, and it allows us to drop our player and to add forces and so on. But when we start our game, we don't want our player to just automatically drop on the ground. We want him to chill in the air, and only when we apply forces, we want him to have some gravity. So we can change it by this body type in rigid body. It has dynamic right now, and if we select this kinematic and press play, you will see that our player is just hanging around in the air and not dropping. Amazing. But when we apply our force, we want him to have this dynamic body type. So our first challenge will be to change this dynamic and kinematic and stuff like that in our script. So let's create new C# script. Create C# script. I already have empty script. I called it bird. You can call it anything you want. Just make sure to drag it into your bird. And let's see. Yes, our bird has script. Let's open our script and see what we should do. First of all, we want reference to our rigid body. So let's say rigid body 2D is RB. And in start, we can say that our RB is equals get component as usual. It will get component from our rigid body 2D. And don't forget parentheses. And that's it. Let's save. So when we start our game, we want him to have body type of kinematic. We can do this by typing rigid body dot is kinematic is true. Amazing. Let's save this script and let's go back in Unity. Let your script compile. By the way, to save your script, you can click on the Control S or Command S if you are on Mac. And see, our bird right now has this dynamic body type, but if we press play, you will see that our bird is not going down but staying still. So our script is working so far. Now, second challenge that we can do is to change its color, because way Angry Bird works, we should click on our player and drag it on the left side and release it. So what we can do, if we select our bird, we will see the sprite renderer component. It has this element of color, and if we click on this color, let's go in the game mode, click on the color, you will see that it's selected white right now. White means that it will just have its original color. But if we change it to red, you see that it becomes red. And we can implement this color changing in our script. So I'm thinking about when we click our bird, it will become red, and when we release it, it will become his original color. And let's go in the script and do that. First of all, we need reference to our sprite renderer. Yeah. So let's say sprite renderer is equal with sprite. And let's get reference in our start. So sprite equals get component, just like we did with rigid body. But this time we need sprite renderer component and parentheses, and that's it. Now, as I mentioned, we need to change color when we click on the mouse. Way we will do it, we will use Unity's built-in method, which is on mouse down. So let's say void on mouse down, which means that it will be executed when we click on our mouse. And we can say sprite dot color is equals color dot red. And that's it. But we also need to go back in original color when we release it. So we will use onMouseUp this time. Void onMouseUp. And we should say here sprite.color equals color.white. It will change our color to its original color. And let's save the script, Control S, and let's see if it's working. Let's go back in Unity and press play and see. As you see, our player is hanging, but when we click on our bird, it becomes red. When we release it, it becomes its original color, which is cool. Amazing. Our next challenge will be to actually drag, to make us able to drag our bird. So let's go back in Unity, and we can use Unity's one more built-in method, which is void onMouseDrag, which will be called when we drag our mouse. Now, we should save our position to variable, so we can say vector free mouse position, and it will be equal. We can get this mouse position with our main camera, and to do it, we can say that our mouse position is equals to camera dot main dot screen toward point. We can get input in parentheses, input mouse position, and that's it. What it does, basically, it gets and it gives us our position from our main camera. And we can say here that transform.position, which is our position of bird, is equals to mouse position. And it will mean that our position will be this mouse position's X, Y, and Z value. But the problem with this code is that if we look on our main camera, as you see, it has this Z to -10, and our bird has Z to 0. So it won't work because it's flat game. Our camera should have this -10. And how to implement this function? What we can do is we can take our mouse position .x, also, comma, we can take mouse position .y, but we can leave our z unchanged. So we can say transform.position.z. What it does, it takes our mouse position's x value, mouse position's y value, and our transform.position will be our player's position. Now it has this red line because we forgot to add one more thing. It should be new vector free. That's how Unity handles new positions with the new vectors. So new vector free, and in parentheses we can say this mouse position X, Y, and transform position Z. So this way our X and Y will be with mouse position and our Z will stay unchanged. So let's save this script and let's go back in Unity and see if it's actually working. So let's press play and see. Here it's our bird, and I can move it wherever I want. And that's exactly what we need so far. So far everything is looking good. But next challenge will be to have some direction and starting positions and some current positions, and to actually make our bird release. And our bird will have some launching power and he will fly after our script. So let's implement that. First of all, in our script, in our bird script, we need few new variables. First of all, let's make public float with the name of speed, and we will assign some speed value in our inspector, and let's say vector to start position. We also will need vector to current position, and we also will need direction. So vector to direction. Amazing. I think that's all we need, these vectors. And when we release it, it will happen in on mouse up. So let's drag this sprite color down and let's see. First of all, in our start, we need our start position to become our rigid body's position. So let's say our start position will be equal to rigid body dot position. So our starting point will be our bird starting position. On mouse up, we also need our current position to be a rigid body dot position, because I will remind you, it will be called when we release our mouse. So current position will be where our bird is at that point. So rigid body dot position. And now our direction should be equal to start position minus current position. Now what it means, I will explain it very simple. Little math we will need here. If we have a look in our bird, and let's change position to Z, our x-axis. Let's say that our player is chilling on the 0 axis, on the x. And let's say that we moved him to -2. So our starting position was 0, and now it's -2. What will be our direction? So 0 minus -2 will be same as 0 plus 2, because 2 minuses will give us plus, and our direction will become 2. And it means that if we take our current position and add our direction, and in this case it's 2, so if we add this -2 to +2, we will get our starting point, which was 0. Amazing. And we need that direction to actually launch our player. So let's drag our bird on the same spot around here, and let's go back in Unity. We don't need it. These green lines, we can delete them, and we should normalize this direction. Normalize means just we are making this vector magnitude of 1, so we can say direction dot normalize with the capital N. Don't use the other one with the lowercase n, parentheses. And if you remember, we change our rigid body type to kinematic. We don't need it anymore, because when we released it, we want our bird to have dynamic body type. So let's say our rigid body is kinematic is false. False. Amazing. Now it's time to actually make some force. So let's say our rigid body dot add force, and here we will say our direction. That's why we needed this direction, multiplied by some speed that we will assign in the inspector. And we can save this script. That's all we need. It's nothing complicated, as you see. Let's save our script and let's go back in Unity. First of all, if we scroll down to the bird script, it has the speed component, and let's say our speed will be 700. Let's press play and see what it looks like. Okay, we can drag our bird, and when we release it, it starts flying. Amazing, guys. We did it. We implemented our flight, which looks very, very fine. Our next challenge will be to actually reset our level, because right now we don't have anything to restart our game. So let's implement that. Let's open our bird script once again. And way we will handle this challenge is that when our player touches something that has collider, our game should restart. And we can use for it on collision enter. So type here on collision enter 2D, enter, click enter, and it will auto compile. And we can say here that when we touch something with the collider, our rigid body dot position, so our bird's rigid bodies dot position, will be equal to start position. Start position is where we are right now when we start our game. So we also should make our bird is kinematic again, and we can say here rb.velocity equals to vector2.0 to avoid any weird movement which our player will have. We can save our script. Let's go back in Unity, let it compile, and let's see. Let's start playing, and now we will have our restart game. Let's touch ground, which has collider, and indeed it's working. It's resetting our position. Amazing. But the problem is that this reset is immediate, and I want to have some time, some delay time before we restart our game. And our next challenge will be to have some time, some delay time. We should implement that by coroutines, and the coroutines are very useful. I already talked about it, and we can use them today to wait for some time. And in on collision enter here, we can say that start coroutine, and in parentheses we will need coroutine name. Let's call it reset delay with a capital R, parentheses one more time. And it's red right now because we should create it, and we will create it with special method with the name of iNumerator. That's how coroutines are working. So type iNumerator and name is reset delay, parentheses, and let's open brackets, and let's type here what we need. In order to wait for some seconds, we can simply say yield return new, wait for seconds, and in parentheses we can type some seconds amount. Let's say it's 3. We can always change it. Also, we don't need those 3 lines right here, so let's just cut them and place them in our iNumerator, and let's save our script. That's it. Now, if we go to our game and start playing, we will see that we will have some time. So let's try if everything is working fine. Okay, we touch ground, and as you see, after 3 seconds we restart our game. Now 3 seconds might be a little bit more that we need. We can say it's on 2 seconds or something, but for now let's keep it as it is. Now it's time to make some boxes and our enemies. Okay, I have this box in my project, and let's place it here. Let's see how it looks. It looks fine. And it needs few components. First of all, it needs collider. So let's type box collider 2D. And it also needs physics. So let's type rigid body 2D. That's it. We can take our box, click on the Control D to duplicate, and let's place it here. One more time, duplicate, place it here, duplicate, place, duplicate, place. So 5 will be fine. I think we can place one more if we want, or whatever amount we want. Our boxes are ready. We can create empty game object called box, and we can drag all of it into our empty game object just to make everything cleaner. And now for enemy, I will use same bird pack. I will just use other bird. So in prefabs bird 3, I'll use this blue one. Let's drag it into our scene. He is pretty big. Let's scale it down to 0.3, 0.3 on the X and Y. And let's click on the flip X. And let's add components. First of all, we need polygon collider once more, and we need physics. So let's type rigid body 2D. Amazing. So our bird enemy will chill here. And let's see how it looks like. Let's press play. And we can drag our player, and yeah. We can crush our enemy with the boxes. Right now, nothing is happening, as you see. First of all, let's take our enemy, which is this blue bird, and let's freeze rotation on the Z, not to have any weird rotation. And we need to code some lines to actually kill our enemy. The way we will do it, we will make our boxes. Let's take all of our boxes, select all of them, all 5 or 6 or whatever amount you have, and you see here tags and layers. We will use this tag. Let's add the tag and click on the plus sign and type here box with a capital B. I already have this created. Now select all of boxes and in tag select box. It will set all of our boxes to the category of this box. And now we will create a new C# script called monster with a capital M. So create new C# script and name it monster. I already have one, as you see. And let's just assign this monster to our enemy, which is Bluebird. Let's see. Yeah, it's assigned, and let's open our bird. Now here we don't need anything like start and update, so we can just delete it. What we need is on collision enter again. On collision enter 2D, click enter, it will auto compile, and we can say that if collision dot game object dot tag is equals to box, what we need to do. We need our game object set active, and in parentheses we will say false. So what it does, when something with the tag of box touches our enemy, he will disappear from our scene, right? So let's save our script, and right now this box tag we assign to all of our boxes. So it should work when our boxes touch our enemy, he should disappear. Let's see, press play. Let's drag our bird. And yeah, indeed, it kills our enemy. Well, technically, our bluebird just disappeared, but it looks fine and it works fine for us and for Angry Bird. And to the next challenge now. Next challenge will be very serious one. Because right now, if you see we can drag this bird in the forward, on the right, in every direction, and it has this crazy movement, and that's not how Angry Birds work. We should have only movement on the left side, and on the right side, we should limit our movement. Okay, so let's open our bird script and let's implement that. We should limit basically our right movement, and we will do it in the on mouse drag, of course, because this is where we handle our movement, our dragging movement. We have here our camera main position, and we don't need this transform.position anymore because we will use vector2s instead. So we can say new vector2 desired position. Let's call it desired position, and it will be our mouse position. Now, in the last time, this method was not working because it was vector free and it was considered z-axis as well. But since we have now vector2, everything will work fine because it will only take x and y of the main camera. All right, now we can say other logic here. So if our desired position is greater than our start position, and we need to say if our desired position dot x, because we need horizontal movement, is greater than our start position dot x, what we need to do. So if we are trying to drag our player on the right side, we should say that our desired position dot x is equal start position dot x. This way we will avoid any right movement at all. And we can say here rb.position, our position to be desired position. That's all we need to limit movement on the right side. Everything looks fine, so let's save the script. Let's go back in Unity and see if everything works fine. It should work. If not, we will fix it in a few seconds, so don't worry. Okay, now I can drag it on the left side, but I'm trying to drag it on the right side. I don't know if you see, but I can't because I'm limited to this point. Amazing. The next challenge will be to limit all of the movement at all, because we still can move it pretty madly here. As you see, we only want this type of movement, and let's limit it to avoid any weird movements and any weird dragging movements, motions. So one more time, let's open our bird script and let's limit all of the movement of our bird. First of all, we need new variable here, which will be float, public float max drag. So it will be our max drag point. On mouse drag, we have this mouse position, desired position, and let's go down, and after it we can say new float. So float distance, let's call it distance, will be equal, and we can use a method by vector2.distance, which is distance by 2 points, and the 2 points that we need is desired position and our start position. Okay, and here we will say our logic. So if our distance will be greater than our max drag, so if we try to avoid our maximum dragging distance, what we need to do? We want our direction to be equal to desired position minus start position. We did similar thing earlier. We will normalize it once more. So direction dot normalize with a capital N, parentheses. And one more thing that we need is to say that our desired position will be equal to start position plus our direction multiplied by max drag. And that's everything that we need to limit our movement in all directions, and you will see when we start our game what I mean by that. For now, these simple lines of code is everything that we need. We just created new float by name of distance, calculated two positions, distance by two positions from the desired position to start position. And if we are trying to drag our mouse beyond our max drag, we'll just simply limit it. So let's save this script, Control S, and let's go back in Unity. Let it compile, and in the bird, in our player, we have this max drag. Let's set it to 3. I don't know, we can change it. So just test how it works. So now we can take our bird, and that's maximum amount that we can go. So it won't go beyond our main camera, beyond our screen. And that looks fine. We can also make this number bigger, and we will have more movement, or make it smaller to have less movement. So play with these numbers and you will get to your desired number, the number that you need. But right now everything looks fine. Let's save our scene. I named it level 1, by the way, and I strongly recommend you to do same, because right now we will work about different levels. So different levels. For the different level, we need at least one more level. So let's first of all create empty game object, and let's call it level controller. It will handle all of our script of the 11 controls. And let's create new C# script with the name of level controller. And let's assign this script to the level controller game object. Amazing. Now, what we can do, let's save our scene, level 1 scene, and let's go in File, Build Settings, and you see this window, this scenes inbuilt. Here we should have all the scenes that we need to be in our game. Right now it's empty. You might have something here, but if yours empty as well, just click on the Add Open Scenes and it will add our level 1 scene, which is our current scene right now. And let's create new level, level 2. So let's copy everything from our player. Just don't include main camera, because we will have main camera in every scene. Anything that, let's copy it. Let's click on the file, new scene, basic build 2D scene, and let's create and name it level 2. I already have created new scene, new level 2. So I just open my scene, level 2. Okay, this new scene will pop up. Let's paste everything here that we copied earlier. And let's make some changes. Let's copy these boxes, place it here. Okay, let's drag our player a little behind. Let's duplicate our enemy as well, and let's place it here to have 2 enemies. And let's press play to have a look if everything works fine, and it will be our level 2. We just need to make sure that nothing is missing and everything looks fine. Yeah, everything looks fine. We can kill our enemies. Okay, let's save this script and remember to name it level 2 exactly like this, because we will need it and I will explain it why. But first of all, let's open scene since we need level 1. So we are back to level 1. We already created this script, so let's open and code some lines. We have this level 1, and since we will be using some levels, we need to add this line of code on the app using Unity Engine.scene management. Just add this line. And what we need to create some array. So monster, since it's the name of our script, and we can say here monsters with a lowercase m. We need also one public string, and string name will be next level name. Amazing. We don't need this start, so let's delete it. Instead, we will need void, not void, of course, void on enable. So let's type on enable, and it will auto compile when we click on the enter. And we can say that these monsters will be equal to find objects of type. Objects, not object. Objects, because we will have multiple enemies. Objects of type, and the type will be monster with a capital M. Monster, and that's it. Now guys, you might feel confused. We need this because way we will handle this situation, we will check if in our scene is monster left, and if it's left, we will just reset our game, our level. But if we already killed all of our enemies, we will go to the next level. That's exactly what we are going to do here. That's why we need these find objects of type, and we set it to monster because our script which is attached to our enemies are monster. And now in the update we will say main logic right here. So we can say that if monsters are dead, let's go with next level. Now we don't have these methods yet, but no problem, we will create them. It just needs a few more parentheses right here, and we are ready to go. So outside this update, we will create void monsters are dead. So let's copy this to have exactly same name, brackets, and we will have one more method, go next level. Let's copy this go next level, void go next level, and brackets. Okay, everything looks fine. And first of all, let's implement our monsters are all dead. Monsters are dead, which is right here. And actually, it should be bool because it's a component of if, it's logic. So let's create bool. Monsters are dead. Amazing. And we can use loops here. And loop I'm gonna use is for each. We can create new variable, so var monster. In new variable name will be monster with the lowercase m, And in monsters, which is our variable, again with the lowercase m, this monsters one. And in the for each monster in monsters, we can say that if our monster dot game object dot active self, and don't worry, I will explain everything right now, return false, and otherwise just return true. Now what it does, it will check if in our scene is our enemy, one of our enemies is active, and if it's active it will be return false, and our game will just restart. And if there is no enemies into our scene, no active enemies, it will go to the next level. Now why we are doing this active self, active enemies? Because way we handle our monster script, we just check that when we hit our enemy with the box, our game object, which is our enemy, is becoming is disappearing. So set active will become true. Okay, let's go back to level controller again, and we need to implement this go next level. That's only thing that is left. So we can say here scene manager, load scene, and in the parentheses we can say next level name, which is public string. Let's save this script. I hope you understand everything, but if not and you have any questions, feel free to ask me in the comments down below. It's nothing complicated really. You can just watch it again, watch it more carefully, and you will get it. Just more practice it will need. Okay, in level controller you will see this next level name. We are in the level 1 as you see, and the next level name is level 2. That's exactly why I told you to name our levels like this. So this is level 1 and the next level will be level 2. But if we start playing, it won't work yet, because first we should go into our next level. So open scene, scenes level 2, and we forgot to add our scene, our level to build settings. And guys, always remember to add your levels to your scenes, otherwise a lot of things won't work. So add open scenes, and we have this level 1 and level 2 as well. So now if we open level 1 once again, where is our script, our scenes level 1, and let's press play and see if it really works. Okay, first let's not hit our enemy, and we should restart. Amazing. Now let's hit our enemy and see. Yeah, indeed, when we kill all of our enemies, our game goes to the next level. Now from the level 2 to level 3 we don't have anything, but that's exactly how you can create a lot of levels, level 5, level 10, level 100. You will just go to the level 2, open scenes, level 2, and you just will change this level controller next level name. So if you are in level 2, you will type here level 3, then you will create level 3, add to the build settings, and that's all. Everything will work. So guys, we did it. Congratulations if you were following me and created this game. You can take this game, implement it with other stuff like Canvas and UI, and design it better, make some more enemies, create some other levels, but it's basics that you need to create your own game. So thank you for watching, and if you like my content and want to see more interesting videos, please like, subscribe and ring the notification bell not to miss any new upcoming videos. And new videos are coming every week, 3 times a week. So thanks and see you soon. Bye bye.